Despite the fact that rockets must-nones are useless and good engines if a rocket cannot be managed in an emergency, airborne rockets appear to be much more strong steering techniques due to when a rocket attempts to spin in the air that was pushed into the atmosphere. Hello and welcome to Z. Please subscribe and hit the bell icon. It will be propelled around it by its nose cone. Returning to its initial position, the rocket has to defeat this outside force. The actual submission of the additionally atmospheric rockets will serve as massive pendulum engines in the back, comparable to the weighted abandoned gravity pendulum, will attempt to draw the rocket into an advantageous position, a line parallel to the surface of the because of the engines it produces. Planet incredibly challenging to control when in the atmosphere, rockets to stronger than before. Overcome this issue. One of those is the usage of control mechanisms. Fins are used as a technique of separation. They divide the air into two halves. One of those air molecules moves more quickly, so the lower pressure is lower than the higher pressure. Air will endeavor to go toward it, cannot overcome the low pressure, and this just barely collides with the fin's wall. Motions that the rocket fins typically regulate, adjusting air pressure with flaps flip the fin over to one side. Create air on the fin's corresponding side. Must make a lengthier journey in the air, moves in the same amount of time faster because you often collaborate using the fins across from them. This is due to the fact that a fin acting alone would bring about this energy that stayed across the mass's center and would consequently add a spin that is additional, term known as a roll. Additional consequence to the term roll, researchers utilize yaw and pitch to explain the rocket's throat movement, and when the rocket rolls, it rotates on an axis. Retaining the current posture of the simply twisting the cockpit, it pitches, and when the rocket tilts, it yaws. By employing the fins, pitch and yaw are manipulated by opposing fins, then we'll move the flaps in a similar fashion. When a direction roll is introduced, flaps moving in opposition to one another rolls in one direction function because one side of the boulder is trying to go in one direction. The rocket's opposite side is attempting to reverse direction so that it spins. Rolling is a crucial movement because almost all rockets carry out maneuvers to align with its azimuth, called roll, where azimuth is the degree of inclination of the orbit the rocket is attempting to reach. Roll to line with its goals. To a rocket can change its azimuth, demonstrate their tilts. It is the only pitch or avoid yawing simultaneously. This enables us to have an in the rocket computer and smaller flight continued, resulting in less mass fins being utilized on numerous well-known rockets, including, despite their high level of control, the Saturn V. The higher you go, the worse your fins are, and will soon cease to function completely. Another method of regulating the atmosphere is a device known as an engine gimbal, or when you use thrust vectoring. To put it simply, to some sort of joint, push your engine so that you can push and gently tilt it go a different direction with your rocket. Engine and thrust are phrases used to describe the fact that you are shifting the engine. The word push stream to control it. Vector denotes the force's direction, therefore it depicts the direction of your effort. In contrast, a gimbal is a type of joint that you can equip a rocket with your engine. There must be at least one engine to control yaw and pitch, while another engine power is necessary for roll control. Is once more, since you must press a rocket at the same time in opposing directions simultaneously in order to manage the rolling. Your engine is chuckling as you flow. Engine must be running in order to use it more outside of the atmosphere. There are precise control techniques available. RCS Thrusters is one of such. RCS stands for RCS and Response Control Systems. Small side engines known as thrusters, a fireable craft that can be used to pitch, yaw, and roll control. RCS thrusters have an issue in that no ordinary engine will do, as an RCS thruster requires engine use that can instantly turn it on and off. Additionally, they must be compact enough to place a few of them along the sides of conventional pumped engines for spacecraft. Take too long to obtain the pumps, while you might use a pressure fed using the engine as an RCS thruster. Hand RCS thrusters are typically fired, it is stated, in a short amount of time between each. Please remedy this issue quickly, people. Hypergolic propellants have to be used in the engine so that there isn't even a spark needed that is associated with the issue to hypergolic fuels are extremely hazardous. There will be some effort taken towards loading. And if there are any people on the spacecraft, then additional safeguards for people would be necessary, but you could utilize a monopropeller or single propellant, one type of monopropellant for thrusters, cold gas thrusters, and a cold engine buster, a single pressurized gas truck. If a fuel tank is used, gas is kept there. When the valve is opened, the gas this produces an engine that can be tanked. Fast switched on and off is not, although it's inexpensive and poisonous, not very effective. Yet another type of decay-based monopropellant engine of fuel is used in that type of engine. Run over an initiator that makes it. This type of engine has a decay and expansion quick times for shutoff, because all you need to turn it on, simply open the valve, or off. Additionally, it is more effective than a nonetheless. The most popular are cold gas thrusters. Fuel is hydrogen, and poisonous hydrazine, caustic, hypergolic, and carcinogenic, must be kept warm, else it will become dealing with ground workers that are difficult to handle. Hydrogen, once you fully hydrated suits made of hazmat with a self-contained oxygen supply, and those cost materials may increase the price of sending a rocket hundreds of miles. This cost hundreds of dollars. Safer technologies have been developed. Options, but they weren't not yet been sufficiently tested for prolonged. RCS Thrusters are not the ideal for missions as a result of eventually running out of a means of resolving this. Mechanical attitude management systems have one of those is a reaction that was developed. Mineral wheels are wheel reaction wheels. Has a motor attached, and with lubricant and balls all around it. Moment the engine is turned on, the bearings will spins if the forces are equal. The polar opposite of how the wheel turns incorporated into the craft. The craft spins as a result of this. Retain control on each of the three axes. It takes 3 response wheels. One roll is free for you and one for the pitch. Well, if the response wheels are broken, whenever the force of friction exceeds the force, most crafts are under the motor's pressure. Have 1 or 2 extras available. You could, to get there, use a control moment gyro. Control your craft's motion, and at that same moment, a gyroscope was used. A rotating wheel spins continuously. This generates a force that is similar to a gimbal. Parallel to the rotating wheel and the perpendicular is the default position. All of the wheels' combined forces cancel out. When the wheels are spun, others emerge. Whenever the forces are out of balance, the spacecraft rotates those both. Techniques encounter an issue known as saturation. Happens as a result of when a wheel stops turning or when they're back to their original positions, the spacecraft begin to spin in the opposite direction. Think of it as a direction when you try to put an end to a spinning wheel, you are pulled along swiftly. With that, the wheels become possible. Need to keep pace consistently and to maintain the spacecraft's straightness. However, the spaceship is constantly influenced by outside causes, therefore the wheels need to exert more force continuously. The wheel will eventually become incapable of. If you spin any faster, you can stop this. The wheels of the spacecraft will slow down. While maintaining the proper orienting oneself using RCS thrusters. Electromagnets are used as a control mechanism when 2 electromagnets are activated. Satellites will either point north or this south. Works good but uses a lot of resources of electricity, and as the situation worsens the further you are from Earth's magnetic field. Thank you for watching, and please don't forget to subscribe and hit the bell icon.